Okay, my name is Philip Melo, and today I would like to discuss with you a new, relatively new, I would say, a very efficient tool that will allow us to bring data from point A to point B. What actually COVID-19 showed us that we didn't have such an efficient tool that allowed us timely to bring data to data exchange between different information systems, between hospitals, public health agencies, and other organizations. Okay, let me share now with you my screen, and I will show you how this tool works. So first of all, I would like to say that FHIR API can be deciphered as fast health interoperability resources. And this is application programming interfaces. And this is not only my opinion, but this kind of tool it's a great step ahead and will revolutionize actually public health and public health informatics. Okay. Just a little bit history. History will start with HL7v2. HL7, it's an international company that produces all these standards. And HL7v2 refers to 1981, when a very successful standard with a high rate of adoption was actually developed. The thing is that HL7v2 messages are used to transmit clinical data between systems, between hospitals, for example, between different healthcare providers, public health agencies. And HL7v2 message might contain information about an observation result, a prescription to send to a pharmacy. So it's a quite a wide range of application of this standard. How it looks, this standard? This standard looks in this way. We have delimiters, which are just vertical lines. And actually, you can see some words that you can identify. Let's say glucose here. This is 153 Fernwood Drive. So like address of the patient maybe. So you can identify some words. But what is the major drawback of this actually standard is that it was designed for different systems and different organizations, and they were free to change some here characters. And therefore, when we receive a message HL7v2 from other organization, we still needed to decipher it in some ways. And it takes lots of time. And of course, HL7v2, it has other drawbacks, cannot be considered as an optimized tool that we can use now that we face different problems, different challenges, such as outbreaks, pandemics that requires fast data acquisition, fast data retrieval, and fast data messaging. So to send data from one place to another. So we cannot say this about HL7 too. So to make it more rigid, HL7 designed another standard, which is called HL7v3. But HL7v3 is very poorly adapted. So for long of my career in digital health, I haven't seen too many organizations that used HL7v3. They complain that it's too difficult, too hard, and so forth. There is many excuses and it's very hard to read here. It is not well readable, and this, as you can see, that it has XML characters here, so it is XML form, but nevertheless it is very poorly adapted. Now we go to another standard which you call CDA. CDA is a clinical documents architecture, and C-CDA it's called consolidated clinical documents architecture. I'm not going to just describe the standard in all detail, but for example, the consolidated CDA is built on top of the CDA because the standard further optimize healthcare interoperability, making exchange of documents easier and more efficient. Okay, so that was quite advanced. It was another step ahead compared to HL7 V2 and V3. And this standard is also widely used. Now, what is FHIR? So before going into FHIR definition and the FHIR, how we use it, I just would like to give you a simple example. So suppose you are in a Chinese restaurant, maybe in China, maybe in other country, and the waiter doesn't understand English. Okay, and you don't know well Chinese. So suppose this situation we consider. So you try to explain something to the waiter, and instead of bringing you, for example, a salad, he brings you all these 6 dishes because he doesn't understand you. That is exactly what's happening with HL7 V2, for example. There is a sort of variance. It is a degree of uncertainty. And that's what it is. And how to fight this degree of uncertainty? And I will just explain to you how we do that. So we don't need that the waiter will bring you many dishes, and you will explain to him that you need only one, and he doesn't understand you, and so forth, so on. It goes on and on and on. And maybe you want this, but you want to change something, he will understand you. So what happens is that in this case, you order a menu. A menu, you just point on this dish, and instead of bringing 10 dishes or 20 dishes, the waiter will bring you this dish and this dish. And this is a resource of the restaurant. What exactly this corresponds to FHIR resources. And now we have 157 resources in 2024. So the number of resources just a little bit growing, and resources have various like dishes. For example, information about patient, his address, his name, where he lives, and this is, for example, another is observation. For instance, there is vitals, his blood pressure, and many other things. So we have 157 resources, 157 dishes. And of course, the client can choose what actually he or she wants. So this is an idea of FHIR. So FHIR has been designed to be a faster, cheaper, and an upgrade to the C-CDA. This standard is based on resources, as I said, which are called building blocks of health information that contain standardized and exchangeable data elements. Okay, so FHIR resources are simple and human readable. This is very important. And FHIR adopts modern web standards like RESTful API. So I will just explain you in a second what does it mean, RESTful API. But I would like to say again here that V2 is old and limited by its own rules. Yeah, because these rules are coming from different organizations who use this HL7 itself. It's very hard sometimes to understand. And this is look like a Chinese waiter with many dishes. V3 too slow. CDI has success, and many companies use C-CDA, consolidated CDA, but we're not going to spend time on these standards. And I would like just to show you another thing. what is the idea of the waiter? So suppose you have now resources, the dishes, what you want you to get, and of course there is no policy in the restaurants that everyone will go to the kitchen and talk to the cooks and explain to them what actually you want. For this you have waiters. So restaurants, they have waiters, okay, and the waiter comes and you try to explain just to him without even knowledge of his language. You just point on dish what you want, and that's it. And this messenger, actually, this waiter, provides you communication interface between you, your menu, and the kitchen. So you just point at the dish, and the waiter goes to the kitchen because he knows exactly what to bring to you. So this is called application programming interface, and application programming interface should be designed in some way that it will can accomplish your orders, that what you want to get. Okay, now if the question would be where it is here, FHIR, and where is API? Of course, FHIR is a menu, yeah, because it is a standard of, it shows the dishes that are available, and waiter is an API. So that is what it is. Now, what does it mean, RESTful API? Because everybody said that FHIR uses RESTful API, or just we can hear just this REST API. All right, so the API are the most commonly used APIs in the world of web services. It is web services, and they use HTTP. It is Hypertext Transfer Protocol to search for web, because when you try to get some web URL, you have to use HTTP or HTTPS, which gives you more security on this search. And request goes to create, read, update, and delete data. With HTTP, you can do that. And they are popular because of their simplicity, scalability, speed, and ability to handle all data types. And with this CRUD data characteristics, we choose this REST API, which we use for FHIR. Okay. Now, advantage of RESTful API. It supports all types of data formats, which is very important for us when we use FHIR. Works well with web browsers. Okay, for example, it can be Google Chrome, it can be other web browser, doesn't matter. Uses less bandwidth, so it is less energy. Does not need to be designed from scratch. Yes, because it's we don't need to write complicated programs and so forth. And easy for most developers. Developers love REST APIs, and mostly they use JSON. Okay, but API can run data in JSON, XML, CSV, but JSON is more preferable, more used. And the website can return you different possibilities, JSON, XML, or TXT, and you can use it what you want. This one or that. So you can change the end of the API request. So FHIR is organized by resources. Okay, so like a menu I told, it is patient observation, for example. Such resources can be specified further by defining FHIR profile. This is very important because FHIR profile, what does it mean? And there is some confusion between resources and profiles. So, for example, we have observation. Observation, it is a resource, this one. But observation also has different elements under observation. For example, vitals. So patient goes to clinic and he has vitals. They say height, weight, blood pressure, whatever. And this one, blood pressure is not observation, is a profile. So what you do, you just show what actually you need. So you need not exactly the whole observation, but you need something. For example, it is we go to restaurant, the example, and you have, let's say, a dish, and you can say the waiters that actually don't need salads, but you need only a piece of meat with something like that. This is a profile, okay, and the whole thing is would be the resource. So a collection of profiles can be published as an implementation guide. We know this, such as the US core data for interoperability. As I said, there is 157 resources currently available. Now, ONC, what does it mean ONC? ONC is the whole Office of National Coordinator, and it plays a paramount role in further advancement of FHIR API, and of course adoption of FHIR for wide communities of users, including hospitals, public health agencies, clinics, private NGOs, and so forth. So because this is it is the most that efficient and optimized tool that exists today. Now, as I said about FHIR profiles, it is FHIR is designed to standardize about 80% of health information and medical records, and the standard defines the majority of existing medical data processes and elements. FHIR profiles allow you to customize resource definition by constraining which elements of a resource are required and which are not. That's what I told you when you go to a restaurant. You say that, look, you bring me this piece of meat, but just a little bit salad, but you don't need French fries. As such, profiling becomes an essential part of FHIR adoption, but each case of FHIR implementation is unique, and so are the resources use case. Let's say now blood pressure. So blood pressure, now it is not a resource, but it goes under observation resource, because we have, let's say, patient, its address of patient, whatever. But a resource of observation is different, and we have here vital signs. And actually, blood pressure is under vital signs, and vital signs under observation. But this is profile. So we have blood pressure, we have temperature, for example, we have lab data, laboratory, we have, let's say, blood glucose. If you want to have it, it will be a profile. It goes under the resource, which is called observation. And this is quite important, and you can build an API, application programming interface, with this information, what is the resource and what is the profile, and we can get the data. Now, what is the vital signs? Blood pressure, let's say systolic and diastolic, and this is what it is. The profile would give you mean blood pressure, and this is very curious numbers. And these numbers it's called LOINC. LOINC, it is logical observation identifiers, names and codes. So for each name in the FHIR, you will have LOINC. So this is number. For example, what is blood pressure? Mean blood pressure, it has LOINC 8357-6, but blood pressure method, it is 41904-4. Now, so each activity under profile or under resource will have LOINC number, logical observation identifiers, names and code. It is very convenient to use it. Now, this is how looks JSON. So it is you have JSON, what is good, but you can read. It is readable. So, for example, you can have observation blood pressure profile. You can read it. So JSON is good on that, compared to, for example, other formats. Now, I want to ask you a quiz. So a healthcare provider requests several medications to be administered to Mr. Ross, let's say. Which FHIR resource could be used to make this request? Okay, let's see now. So as I said, we have 157 different resources, and some of them are we call service resources, and one is this service request, medication request, a device request. Since it is medications, okay, of course it will be here a medication request, and I will just highlight it somehow. Okay, this is medication request. It is a correct answer. Okay, now another question. LOINC is a database and a universal standard for primarily identifying. Okay, so you have to check what it is. It is medical laboratory observations. It identifies clinical documentation, radiology use case, and long-term patient. Of course, it is medical laboratory by definition of LOINC. So for each medical laboratory observation, it gives you number, okay? But it doesn't identify clinical documentation. It doesn't identify radiology. It doesn't identify long-term patient care. This is correct answer. Medical laboratory observations. So what I will do now is the following. I will show you how we can use the FHIR API, and I will show you API to move data from electronic health records, for example, to clouds. We use MongoDB, okay, which is I highly recommend this kind of portal because it is free, and we can store and process data on that. So let me just show you. Give it a second. Yes, so what we have now here is this one. This is our platform. And in my previous lectures, I already demonstrated this platform. It has quite a large number of different algorithms, data, it has lectures, it has electronic health record access, decision support system, it's everything, so it is quite universal platform. And now we look at the the FHIR server. So we just go here. Yes. And we have FHIR server. And what I will do now, I will run the API. And this is API looks like. You have here URL from electronic health records, and I will just click on it. Okay. Yes. And now what I will do, we'll see now, FHIR server. Okay. So it takes us a couple of seconds to move data from electronic health record without any programming. I moved data. I just need to know URL, actually, what it is, and where to move. So this is API is doing, and also in terms of the data format, for example. So a few characteristics, and you can build a API. It depends on your problem. Now, what happens is we can see what actually we got from electronic health record. I need to just click on that, and we have they send us patient, which is a resource. You remember I told you that we have patient as a resource, and we have here identifier. We have, let's say, a gender, male, and we have birthday. We have address, and let's say we see open something. Let's say name. Name. We have three names. One is Chalmers. That we have a given name, Jim, and we have here family Windsor. So we have three names. So that we received from electronic health records. We have received something more and so forth. But this is an example that how FHIR API accelerate, and instead of just writing programs or just trying to decipher HL7 v2, we used FHIR API, and we just got this data in MongoDB within a few seconds. And of course, we can use, we can take different, any information, not only this information about patient resources, but whatever we want. And we can build other API using this simple program that what I showed you. All right, thank you for your attention. And I encourage you to use FHIR API for your work, because it gives you the possibility to get and transmit data in the most efficient way. Thank you.